Hello everyone, am I audible? Hello. Hello. Yes, hi. Am I audible? Yes, am I audible? Okay. So we are starting with AI ML. So anyone has any idea what is artificial intelligence, what is machine learning? Yes, no. Okay, let's wait for more 5 minutes and then we'll start. Okay. So what's AI? What's artificial intelligence? How can you give a shortest definition of AI? Yes. Okay. Is my screen visible? Yes, no. Okay, so let's start with introduction to AI. Introduction to AI ML. AI, here's the shortest definition that I can write, or what we are going to see in this webinar. It is artificial intelligence and machine learning. We'll be seeing what is AI, what is AML, and we'll be seeing a short project on AI based project and using the pre-trained model that is trained on machine learning. Okay, so artificial intelligence and machine learning are transforming how we build a software. Okay, how we build an application, how we build any app, any data science app, or any data visualization techniques, or whatever we are doing. Artificial intelligence and machine learning are transforming that, like making it easier, making the repetitive task easier. Okay, so this webinar explores core concepts and demonstrates a practical implementation through a real world image classification project using PyTorch and Streamlit. Okay, so we'll be seeing an image classification project using the library that is there in PyTorch, Python, that is PyTorch. Okay, and we'll be visualizing it using Streamlit platform, wherein we'll be seeing the UI. Okay, and we'll be uploading some images and making that model to predict what image it is. Okay, so this is the basic agenda behind this webinar. It is basically combining both automation and machine learning that enables machine to think autonomously. Yes. So in the comment box, there's a attendance form. You need to fill up that attendance form. Okay. Okay. Let's proceed. Now, what is AI? Understanding artificial intelligence. Artificial intelligence enables machines to simulate human intelligence, wherein we are putting the human intelligence into artificial or computers. Okay, we are making computers this powerful that they can understand or they can think like a human. Okay, they can work like a human works. Okay, so this is artificial intelligence, learning from data, recognizing patterns, and making decisions. Okay, AI systems can process vast amounts of information faster than humans, continuously improving their performance over time. So let's take an example. Like we have a data set about of million and billions of rows. Okay, so for understanding the relationship between those rows, for understanding the relationship between the columns that it consists, the data set that has multiple columns, so for understanding that relation we need will be needing around a year to understand that billions and millions of data, right? But using the artificial intelligence, if we use a particular library, we can easily understand or process that vast amount of data. So that's the use or that's the power of AI. Okay, now what is the advantages of AI? It automates the repetitive task, freeing developer for creative work. Okay, uh, the repetitive task that happens like developing the UI, it is also a repetitive task, or designing a graphics. Okay, or gathering the information. Okay, all this is counting the notes, counting the amount, all this is repetitive task that is been done by AI itself. Like we can avoid doing the repetitive task and go towards the creative work. Okay, so this can the repetitive task can be done using AI. Okay, this scales effortlessly to handle millions of data points. We can handle millions of data points within an hour, you can say. Okay, provides insight humans might miss in complex data set. We might miss, like we might misinterpret some columns, some rows, or you can take an example. If we count a particular notes, okay, we count it 2 to 3 times. Okay, like we have a particular bundle of 500 ka notes and we count those notes, that how much money do I have. Okay, so we count it like 2 to 3 times for understanding that yes, this much or notes I may have. Okay, so for sometimes we miss out some information, we miss out some notes, so we count it again and again. Okay, so for getting the clarity. So this AI, if we give the data point to AI, it can understand within a minute and it won't give me any error, like it won't mislead or misinterpret some part or miss some part. Okay, so this is the advantages of using AI. It provides insights humans might miss in complex data set, as I said, operates 24/7 without fatigue. A human can like work for 8 hours a day, okay, or 12 hours a day, you can see, but he needs a rest of 12 hours or at around 8 hours a day. Okay, so he cannot, a human cannot, he or she cannot work for like 24/7 continuously for a month, for a year, or anything. Okay, but this artificial intelligence can work 24/7 without a fatigue, which means without a failure. It adapts and improves with more data. More data we give to artificial intelligence, it will like adapt to that data and it will predict the values, or it will understand the data set that in that way, and it will give me more accurate values every time I pass the new data or pass the new data for prediction. Okay, so this is what AI is. I hope so AI is clear, right? Okay, now let's see what is ML. ML stands for machine learning. Okay, machine learning is the subset of artificial intelligence. We have a like bigger or superset, you can say, that is artificial intelligence, and in that we have a subset that is machine learning. Machine learning is like a technical part of artificial intelligence wherein we work on the rules, we work on the models, we work on the algorithms that we pass to AI. Okay, all that thing is done in machine learning part. So machine learning is a subset of AI, as I said, where systems learn from data without explicit programming. So here we do not need the programming, but we need to know the rules that or the algorithms that are there. Okay. So instead of writing rules, you provide examples. We provide the examples of model, like we have supervised machine learning, we have unsupervised machine learning, we have many algorithms that are already built in this machine learnings or in these categories. Okay, so we just pass that model to our data set and we make it understand that this is my data, you need to learn from this data and predict the future, predict the output for the input that I may give in the future of according to or based on this data set. So this is machine learning wala part. Now, accuracy at scale. ML models excel at finding subtle patterns in massive data sets, often outperforming rule based systems in complex tasks like image recognition and natural language processing. So, this ML models are like, if we use the algorithms, if we use the ML models, they excel at finding the subtle, excel at finding the patterns. Okay, they understand the pattern very quickly and like predict the future according to it, predict the future inputs that I may give, the output for that in a very best way, or it can give me the accuracy that it gives me. Like if the accuracy is 50 and above in the positive, okay, 50% and above, or you can say the probability that is 0 and 1, it is between 5 to 1. Okay, 0.5 to 1 in the positive number. So that model is very accurate for a particular data set. Okay, so this is where accuracy at scale matters. And then it is continuous improvement. Models, if we provide a particular, we have built a model, let's say we have built a particular model, and then we have more data that has received by my side, like I have passed 10,000 of data for a particular model. Okay, and then I've trained that model, it is predicting at around let's say the accuracy is 82%. Okay, and it is predicting all the values. Now, if I have received more 10,000 of data, 10,000 of values, okay, so I can give that value to the model again, okay, and then I can reframe that model, and it is now more accurate, like it is giving me the accuracy of 85 to 86%. So my accuracy has been increased to 4% by just giving it a data set again. So this is what ML is, machine learning is, it is understanding the data set. Now what we are going to see is, we are going to see a Python and AI for image classification. Like if we are doing any AI related part, we need to know Python, because Python has many libraries that are already available into it, and Python's syntax are very easy, so we can do all the AI related work or AI ML classification models predictions, or build a model using AI in Python very easily. Okay, we can write like around 100 of lines of code, and we can build one model in AI or in Python. But in other programming languages, we need to write many lines and many lines of code, and also the libraries are not available, so we need to build those or write the code for that library also. And it's like and there are also syntax, like we need to write in the curly braces, we need to give a particular parenthesis. So all the syntax are there in other languages, but in Python we can just we can like write a code, and understand the code itself, and in 100 lines we can build one model. So we are going to see Python with PyTorch. Okay, we are going to see the PyTorch library for image classification. Okay, so what Python dominates AI development with its simple syntax and rich ecosystem. PyTorch was developed by Facebook AI Research. Okay, it offers dynamic computation, graphs, and intuitive debugging, perfect for rapid prototyping and production deployment. Rapid prototyping means rapid building of a particular category, and we can deploy the projects in this PyTorch as well. So what is this PyTorch? This is a computer vision library wherein we can do the image classification. It is a machine learning pre-trained model. Okay, so we can use this PyTorch. Our project is to build a real-time image classifier that identifies objects through webcam or uploaded images. If we upload a particular image, it must identify or classify which image is this, and it will give me a particular name of that image. Okay, if I'm passing a particular breed of dog, okay, for example, I'm passing German Shepherd, so it will give me the name. I'll pass a image. Okay, it will give me the name that this is this particular dog. Okay, so prediction, it will give me as German Shepherd. So we will use a pre-trained ResNet 18 model. Okay, the ResNet 18 model is used for face recognition as well, and it is used for image classification as well. So this is a pre-trained model which is built on thousands, millions of data images that has been passed to it. That is ImageNet. Okay, so we will be using a pre-trained model as for this live and deploy, and we'll be seeing how can we deploy it on the Streamlit for an interactive user experience. Like for example, if I'm passing in my code only, so it won't be like exciting for you also. So we'll be seeing a user panel that is using the Streamlit. We will be seeing a user panel UI wherein we will be passing the files or the images, and that UI will give me the prediction. Okay, it will give me the top 3 predictions. So the first part what we will be doing is load the pre-trained model. First we'll be loading a pre-trained model, that is PyTorch. Okay, we will be processing the input images. All the input images that I pass, it will be processed and it will generate the predictions. Okay, and it will display in the Streamlit UI. So yes, any questions so far? Have you understood what we are going to do? Yes. Okay. I have created one folder. Okay. In that, I have created one file that is liveapp.py. Okay, liveapp.py, we will be importing some libraries that is we will be needing for like displaying part, as well as for importing the model that is already available, and pre-trained model. As I said, we'll be using a ResNet 18 pre-trained model, and we'll be using a Torch Vision library for doing the image classification part. Okay, so these are the imports. Let's understand what all this import says, what all this import mean. Why do I need to import these libraries, and why only these libraries? So as I said, PyTorch is like, I have a slide for that also. I'll just show you that part also. Okay. Why Streamlit? Streamlit transforms the Python scripts, all that I write, the code that I write, into interactive web apps. Okay. So mostly, if we are doing local hosting, or we can do the deployment as well by the paid version of Streamlit to the public. Okay, deployment to the public. But for the locally deploying, we prefer the Streamlit library that is already available in Python. So it transformed the Python scripts into interactive web apps, and bridging AI code with user interaction. Okay, the core capabilities of this Streamlit is that it creates an interactive controls. We can upload the file by simply 1 to 2 lines of code, and then webcam integration, we can do the webcam integration in that, like we can give the access to webcam, our system's default webcam as well. Then tabbed navigation and dynamic rendering. Tabbed navigation, which means what, I can go from this nav to that nav, or this link to that link, or multiple links. Okay, and dynamic rendering. Now, key takeaway is that Streamlit builds AI app frontends with minimal code. If you can see over here, I've written only this much of code, and we have built one model using this code. Okay, it's around 102 lines, only 102 lines of code, and we have built a model. I'll be showing you the output. I'll be executing this, but for now, let's understand what this libraries goes or stands for. Okay. Now, what this PyTorch does? PyTorch is the brain behind the AI models. AI models just it contains the models wherein we do the image classification, or we works on the images, we work on the detection part as well. So this is PyTorch. Now it contains the neural networks. Neural networks means what? It is flexible building and training of complex neural networks with auto differentiation. On neural networks, consider a networks like a match the following ka blank that you had done in your classes. Okay, so we have one part we are showing the relation by drawing the lines between them. So this first part is related to some first and second part. Okay, so we are showing the relationship in this neural networks. Then we have tensor operations. It is efficient optimized tensor operation for multi-dimensional arrays. Okay, so we can have multi-dimensional arrays. Multi-dimensional arrays means what? It is like nd of arrays, which one array can consist of multiple arrays, and that multiple arrays can consist of multiple arrays. So there must be a relationship between this point to another points. Now in this neural networks, we are not doing the text classification or text differentiation or understanding the relationship between the text. We are understanding the images, so that images is converted into, you can say, a million of pixels. Okay, those pixels and are seen using the numbers. Okay, so those numbers are stored in this md arrays, that is multidimensional arrays. Okay, so then we are doing is gpu acceleration, that is we are training the model onto a gpu graphic processor unit. Okay, then this model is built, or it has already trained on this patterns. Okay, so this model has been trained on this all these patterns, and we are just using the pre-trained model. So we are just accessing this model, and will be passing our data set and making it to predict the images that I pass, or the images or the objects that I show to the camera. Okay, so PyTorch provides the core infrastructure for building and deploying ML models. So it provides me the core infrastructure wherein I can build the model and I can deploy that model too. So it is favored by many researchers, production teams for its dynamic computational capabilities. Okay, so we were seeing PyTorch, about PyTorch. Now, next library we were using is Torch Vision. Okay, it is computer vision made easy. Torch Vision, what is Torch Vision? Torch Vision extends PyTorch. So for computer vision, like offering a pre-trained models, then image transformation, transforming a particular image, you can say like I will be transforming any type of image, any size of image, any like any color or blur image as well. So this torch vision, what does this torch vision do is it transforms my images. Okay. Now pre-trained models access state of art. Pre-trained models like ResNet and MobileNet. Okay. Image transformation, what does it do is perform image transformation like resize, crop, normalize, and augment. Then standard data sets utilize benchmark data sets like Cypher, MNIST, and Coco. Okay, so it is already passed, the data set Torch Vision is already trained on this data set. Okay, so we are using PIL. We are importing PIL also for our model. Now, what does this PIL stands for? It is Pillow, your image reader. What it does is it is the image reader. It will read my image. It will understand my image. It will open and load images. It will do image manipulation. Then format the conversion. Then what does an open and load it does is it will read the images from the disk. Okay. Then image manipulation may it will do resize. What it will do is it will resize the image or rotate the image, crop the image, and filter the images, right? And then format conversion may it will convert my image to a particular format. Okay. So this Pillow is the essential bridge converting raw images, like whatever image that I give to my model. It can be in a format of file or webcam into Python readable object. Like we need to convert that image to understand or to model to understand that image. So what does PIL do is PIL will convert this image to Python readable. Okay. And then one more library we are importing is this NumPy. In NumPy, what are we doing actually is, what does NumPy stands for? It is mathematical foundation, the library that is used for understanding the maths behind any arrays. Okay, so this is NumPy. NumPy is n-dimensional array and the core data structure for scientific computing. If we want to do any scientific computing, if we want to work on neural networks, if we want to like see the numbers, understand those numbers, so we use NumPy, enabling efficient array operations for all AI frameworks like PyTorch. Okay, so array operations are vectorized operations for C speed performance. Okay, then data interchange, and then memory efficiency. It efficient contiguous memory location. So this is about NumPy. And then one more library we are using is OpenCV. Now what does this OpenCV do is it will give the access to my webcam, which is my webcam, the default camera that I have in my laptop or on my system or on my any system. Okay, so it will give that access to my webcam, and it will like create a screen or a frame for processing the images that I give, the objects that I pass to that camera. Okay, so it will do is visual overlays. It will and we can add the text in that webcam or frame part as well, like it will do the real time annotation. Okay, so the complete technology stack we need is the NumPy for mathematical foundation, PyTorch and Torch Vision as AI model infrastructure, PIL plus OpenCV for image processing layer, and Streamlit user interface. Okay, so this all libraries are needed. I hope so this libraries are understood by you why we are using this particular library for the project we are going to do, image classification project. So this integrated stack delivers a seamless AI application from foundational math to user interaction. Now we will be seeing the AI pipeline, like what we need to do. We need for tracing the data flow from user input to AI prediction is vital for debugging and optimization. Okay, So we will be seeing the AI pipeline, like what from the start to the end, what it will be looked or displayed as. The user input will be given, like image will be uploaded or captured. Okay, pre-processing will be done, wherein we will be transforming to model format, wherein we will be transforming the images that I give to it into the model format. Then model inference, wherein AI will make the predictions. And then output display, wherein we will be displaying that output. Okay, it is optimized for performance. Each stage ensures real-time responsiveness. Okay, now let's move towards the code we were doing, seeing. Okay, describe what is libraries. Libraries are like already available modules, already available code that is there in Python. Okay, already available file, you can say, wherein the functions are already written. I just need to use the function, call the names of those functions on my data set, and so I can work on my project. Okay, Nilesh? Do you use any separate tool for maintaining or streamlining the workflow? Yes, we can use many tools, like we can use Notebook LM, we can use like many tools are available. You can search for it. Okay. So have you understood till now why we use a particular library and why we are using those libraries in our project? So it will be very interesting project. I'll be showing you the execution as well, or should I show the execution now and then we'll be seeing the code? Yes. So it will be like interesting, more interesting. Okay, now let's execute this first. Streamlit live app. Okay, so you can see many. If I'm typing Streamlit run live app like the file name, so it will give me two URLs, that is local URL and network URL. Network URL, I can run this URL on any system, on my phone or as well as on another laptop, or you can see another system. Okay, so that's the reason we are using the Streamlit. So let's see, it's getting loaded. Okay, so this is the front end part that has been done using Streamlit. Okay, I'll just browse file over here. Let's put this cat image. Let's see what it predicts. Okay, so yes, it has been given a. Yes. So we are getting the top three predictions, wherein first prediction we have got is Persian cat, and it has given me the percentage, how much percentage it predicts that it is a Persian cat. Okay, how much percentage it is truth, or you can say possibility. Okay, probability. Okay, so there we get, usually we get the probability that is in the number from -1 to 1. Okay, wherein minus the number, negative the number, the it is not mostly probable, or you can say matching concept or matching data. Okay, so we have gotten 83.51%, so it is 0.83 probability. So It is giving me as Persian cat. So yes, this is a Persian cat, and it is giving me 2.21% as Angora. Let's search what is Angora. Okay, it is giving me this wool. And what is candle? We can search the candle too. So this is the candle. It is giving me 0.8% as candle. So it will be like around 0.08%, right? And then let's put another image. Let's put this cup 2 wala image. Open this. See, I've gotten coffee mug as 50.73%, cup as 18.68%, and pitcher as 9.51%. Let's see what is pitcher. Okay, so this is pitcher. Let's put another image. Let's put this cup. Okay. Okay, it is giving me cup as 90.09%, coffee mug as 6.46%. Okay, let's put another image. This mask. Okay, M2. It is giving me mask as 95.56%. Okay, running shoes. Okay. So again we have gotten running shoe 87.38% possibility. It is giving me iron also as the prediction, but it is only 4%. So not an iron. Are we left with something? Yes. For the dogs over here, dog 2, dog 3. If we pass a particular image, okay, let's pass this image and open this, it will give me the breed of that dog. You can see the Clumber has 90.76%. Let's search this online. What is Clumber? You can see this image. So this is Clumber. So it has given me the breed of that dog, not only the dog but the breed of that dog. So what is English setter? Let's search. This is English setter. Okay. So it is giving me that 3.93%. It is English setter, but the Clumber part or the Clumber prediction is 90.76%. Okay. Now I'll pass this dog image also. See, it will reload itself. Okay. So it is giving me Golden Retriever as 69.12% and Clumber as 7.49 and Labrador Retriever as 2.54%. Now one more prediction, that is dog 2. So it is giving me German Shepherd 48.3%. Okay. So in this way, using this code, we can pass anything. Okay. If we pass this shirt, it gives me jersey. Okay, not the t-shirt, jersey. So in this way, we can pass any image and we can check for the predictions it can make. If we pass this mask, what it gives me is, it gives me gas mask as 17.83% and handkerchief as 15.07%. So it is not like that ki it will give me proper output or proper answer for everything I pass. Like for example, if I pass this cat wala image, okay, this cat one, so it is giving me as Egyptian cat. Now let's search what Egyptian cat look likes. It look like it's like this. Like go to images wala part. Okay, so because of the ears, it's giving me as Egyptian cat because of this standing ears. So in this way, we can do the prediction. I can show you about the webcam prediction also, but because of my webcam has the access into this current webinar, so I cannot give it the access. It will give me an error for now. But yes, you can go through this code and you can build this part also, and you can run on your system. the webcam prediction wala part. But this upload image wala part I'll be showing you. Okay, so yes, so have you seen the execution wala part? Yes, everyone. Okay, let's go through the code. I'll just stop this, control C. Or we will run this and I'll show key how it's happening. Okay, so these are the libraries I have explained you why we need this particular library and in which way we need this particular library. We have seen all this. Okay, now let's go to our code. uh, First of all, we need Streamlit for the UI, Torch for like doing the AIML predictions, torch.f function for using a function that is this wala. Where is f? Top k functions. It will give me the top k predictions. Okay, over here top k functions, and softmax will remove the all the like it will give a particular image properly to my torch library for doing the prediction. Now torch vision may say we need models, we need transforms torch vision dot model say I need resnet 18 weights and pil for doing the processing of image to understand python to understand my images, numpy for mathematical, and cv2 for webcam access. So what is this doing? Streamlit is for ui, as I said, and this is used to create the web app interface. Okay, like if I want the buttons, if I want the tabs, if I want to upload the images, if I want to give the webcam display. Okay, so this libraries are used. Okay, then this two libraries, what this import mean is we need a pytorch library for loading ai models. Okay, so this is loading the ai model and running the predictions. Okay, so f provides me the function like softmax. What does softmax do is it will turn the model output into probability. Okay, the model whatever output it gives me, it will be turned into a probability, and in that probability I am turning into a percentage. And what this pil import image will do is it will convert my image. Okay, it will transform my image to python understandable or model understandable. Okay, then numpy and cv2, as I said, numpy for internal arrays and cv for webcam access. Okay, now let's start. Now here we have st.set page config. Okay, we are giving the page title as ai image classifier demo and layout is wide. Okay, you can see the layout is wide and ai image classifier demo is the title over here. Okay, then what we are giving the title of that streamlit page is ai image classification with pytorch plus streamlit. So you can see the title over here. So this is the title. Okay, then we are writing some description about this. So this is the description over here. This is the description. Okay, now we are loading the model. We are using this at the rate st.cache resource because we are caching the model. We are loading the model over here. Okay, so we are loading the pre-trained model. So we are using the function define load model function. Okay, then we are writing the weights as my variable. In that I am passing the caches model, that is resnet 18 weights dot default for improving the speed. Okay, so this caches the model so it load only once. Okay, The model will load only one, it won't load again and it won't go into a loop. So that's the reason I'm passing the weights over here as default. Okay, and in this model variable, what I'm storing is it will load the pre-trained weights. Okay, so it will load the pre-trained weights in this function, models ka function, that is racenet 18. Okay, if you just hover over here, you can just go through this part. What does this weights do is it pre-trained weights to use. Okay, it is deep residual learning for image recognition, all that models related the function in this models. Okay, resnet 18 model. So next what we are doing is model.eval. Now what it will do, it will load the actual resnet 18 architecture. Okay, the architecture plus the weight. So in this model, it will load the architecture as well as the weight. Now in this labels, what I am storing is I will store a model. Okay, so puts the model in evaluation mode. It will put the model in evaluation mode. Okay, and here we are loading 1,000 category names. Okay, in this categories there will be a dog, there will be a, like what we have done over here, we have seen the dog ka execution we have run, or we have seen dog. Okay, we have seen cat, we have seen cup. Okay, so we have seen shirt. So all these categories will be loaded in this labels wala variable, and we are returning the model and labels. Okay, so this is what we are doing in this function. Which function? Def load model function. And we are calling this model comma labels is equal to load model. We are calling this function over here to load everything once. Okay, now over here what we are doing is we are pre-processing. Now in pre-processing we are transforming the images or the past image. Okay, we are transforming the images or we are processing the images. So what we are doing is every image must be converted to a particular format wherein that AI model can understand. So we are using this function, that is transform.compose, wherein we are resizing the image to 256. Okay, 256 pixel, that is a standard model requirement. Then we are center cropping that to 224, because we crop the model to 224 into 224 pixel size, because that model or ResNet model requires this cropping wala part. Okay, and we are converting it to a tensor format. We are converting into, bro, what's happening? Okay, so we are converting this to tensor format. Tensor means what? We are doing a PyTorch format. We are converting it into a PyTorch format. Okay, to understand, to model, to understand that. So we have done the pre-processing wala part over there. I'll just minimize this. Then the next part we are doing is prediction. Okay, we are predicting the images, or we are predicting all the things, objects that we pass. Okay, so we are using a function that is classify image. In that, what we are passing is image PIL. Now what is image PIL? Image path. Okay, so image underscore t, then what we will be doing is we will pre-process this image underscore PIL. So pre-process, in this pre-process we have passed the transformation wala part. So every image that goes into this function, it will pre-pose itself, that is it will transform, resize, and then center crop into a particular format that a model needs. Okay, so in this image underscore tree we will pre-process that image. Then batch underscore t, image underscore t dot unsqueeze. Unsqueeze में क्या होगा, you need to understand that ये PIL image ले रहा है, right? It will be taking the PIL image, that is it will be transforming the image, it will be pre-processing the image, and then we will be doing unsqueeze, wherein we will be adding the batches. Okay, so we will be adding the batches ka dimensions in this. So shape will be like 1 into 3 into 224 into 224. Okay, so what is the shape? It will transform and squeeze in itself like a particular image that I pass. It will be giving a batch dimension for that image. Okay, and then in this with torch dot no grade function, and we are passing as out is equal to model batch underscore t, it will run the image through the model to get predictions. Okay, so what it will do is it will pass this batch t model to all the categories in my model. It will run through the model to do the predictions. Okay, so what does this no grade do is it will save my memory and speed up the interface. It will speed up the interference. So this is the work of this no grade class. Okay, now next we are creating one variable, that is props, and we are passing this f. Okay, we have imported f function, so we are passing this f, and in that f we have a function that is softmax. What will this softmax do is it will convert the output, okay, the logits, to real probabilities. So whatever we get over here, it will be converted into probability. Okay, so you can see over here how it works. It will take the input as tensor, and dim. This function doesn't work directly with NLL loss. Okay, so what it will do is it will convert my model's predictions to probabilities. Okay, and in this top underscore probs and top underscore idx's probs 3 means what? Top 3 probabilities. As we have seen, we are getting the top 3 probabilities. Okay, and we are passing this probabilities over here. Okay, and we are just storing in this 2 variable, and in this spreads predictions, or you can say spreads variable, we are getting those top 10 top 3 predicted classes. Okay, so how we are getting those is we are passing the labels. We are getting the labels at dot item. Okay, idx dot item, getting the label like we have got golden retriever, German shepherd, and we have gotten clumber. Okay, so those are my items. Then float probability. Okay, probability in the float, that is point. Now for prop in zip, top props and idx's. Now for label, what we have to find this two part for what? For the prop. Okay, prop comma idx, where in prop comma idx, in this top props and top idx's, which is over here, and we are just returning this spreads or predictions. Okay, so this spread stands for predictions. So in this we are getting the predictions. Okay, I hope so clear till now. So there's the certificate link provided in the comment chat box. You can just go click on this link and give the quiz, attempt the quiz, and get your certificate. Okay, so we'll just finish this. Then this is all the UI wala part, wherein we are giving tab 1, tab 2 as upload image and webcam. Over here you can see upload image and webcam. Okay, then with tab 1, what in tab 1 what all we need is we need to upload image. So file uploaded function in Streamlit we are using, and we are passing the label as upload an image, and which type of image do I want: JPG, JPG, and PNG. Okay, now if the uploaded image is in the format, we need to open that image and we need to convert that. If it is in another formats, we need to convert it into RGB format, and we are storing this. Okay, and we'll be showing that image as well, and we are passing this spreads function में that classify image function के under this image. Okay, and we are giving a subheader as predictions, and we are using the for loop again, wherein we are passing the label prop in this spreads. Okay, in this spreads variable we have label as well as prop, so we are just printing that label and prop, but we are printing now in percentage format. So I'm multiplying this prop, that is I'm getting in point numbers into 100. Okay, and I'm giving 0.2f, which is I need two numbers after a particular point into a percentage format. Now for webcam access, now st.write, turn on your webcam to classify objects. This is the written part over here, you can see. Okay, then session state, if camera is running, if my session state is now currently running, my camera is running on a particular platform, so I cannot access this, so it will give me an error, false. Okay, then we are creating a start button, and we are creating the stop button over here. We are creating an empty frame zone first, then we are capturing the using CV, capturing all the objects that are passing in this frame using video capture. Okay, so if not cam, cannot access the webcam, if else wala part is over here. Okay, and then else ke andar if it is not open, so it will give me I cannot access. If it is open, it will go into this part. What it will do is it will read the camera, it will convert the BGR to RGB, as we have seen in the face recognition wala part, image pill. Then we are converting, classifying that images using this, and we are giving a text, passing a particular text over here. Okay, so we are giving the font frame text and frame zone dot image, and we are releasing the camera. So that's all. You need not to focus on this webcam, like mostly it has been used for object detection. You can go for this, but for now I've shown you the execution of this much part. Okay, so yeah, I hope so. We are, yeah. So this is the UI that is used, that is built using Streamlit library that is there in Python, and we have done the upload image, we have done the prediction classification wala part using PyTorch, and for webcam access we have done using CV2. For doing any numerical part, we can use NumPy. Okay, so this is all about PyTorch. I'll just show you the PPT wherein we can see the steps more clearly. Okay, so first step what we have done is we have captured the user input. Okay, two inputs. Okay, two input methods were there. We can upload the file, and we can give the webcam capture, we can do the webcam capture. Okay, then second step what we have done is we have pre-processed for AI. Like we need to convert the images or the files into a particular format wherein AI models can understand it. So what we have done is we have resized to 256 pixels, we have center crop to 224 into 224, and we have converted to tensor. Then third step what we have done is send image to pre-trained model. In that we have loaded the ResNet 18 and model over here we have loaded it. Okay, this is pre-trained, has learned to recognize 1,000 object categories from millions of images. Okay, then pass image through model by out is equal to model batch 2, and it will like understand what model or 1,000 raw numbers logit. It will give me a logit or probability of a particular matching category. Okay, now next in fourth step what we have done is we have converted the logits to probabilities. So using this softmax function we can convert a logit or any possibility to a probability. So probabilities between 0 and 1, all probabilities sum to 100%. So we have seen that using the percentage. Over here example output is given. Then select top 3 predictions. We have selected the top 3 predictions over here. We have extracted top 3 predictions by using this line of code. Instead of overwhelming users with 1,000 predictions, we select only the top 3 most likely categories. Improve the user experience and provide the context. Display the predictions in Streamlit. What we have displayed, we have uploaded the images, we have done the live webcam feed, we can do instant result, like we need not to refresh the page or cancel the already done prediction. We can just upload a new file and it will do the new prediction. Okay, as we have seen. So yeah, that's it. So that's it. We are done with the AI ML introduction and a project we have worked on. Okay.